Hello everybody, welcome to another C++ tutorial brought to you by RProg. And in this one we're going to be talking about arrays, which essentially means we're going to be talking about probably a whole bunch of things because there can be a whole slew of problems behind raw arrays in C++, but they must be tackled and dealt with. So let's talk about what these guys are exactly. What an array is of any type is just data that is stored sequentially in memory or in continuous memory. I can't really say that word, but it's simply a leftover byproduct from the C language from where C++ is built. And basically what I mean in simplified terms is C++ is derived from the C language. So there is a lot of things such as I can access the string header file from the C standard library. It's because everything that was in C is in C++. It's, hence the name C++, C plus 1. So I'm not meaning to give a background lesson of C++, but it really defines what an array is. It's about as primitive as you get when it comes to dealing with uh, basically a containment of data types. So, for example, let's say we're going to pick on the integer type to start out. In order to store 1 through 5 through memory, so we're going to represent these as memory addresses right now. Let's say that. There we are. That's what it would pretty well look like in memory in terms of using a raw array. Now later on, if we have enough time, this don't drag too long, we'll look at the standard library and see the alternatives, safer solutions, and things of that nature. But as of right now, let's go ahead and dive right in. What we're going to do is we're going to go ahead and pick on the integer type. And I'm going to use what's known as the index operator, or also known as the subset operator, either or. I'm going to refer to it as the index operator, array index operator. And in this case, I'm going to declare the array size because I'm just going to simply declare the array itself empty. Now, what I'm going to do, the reason why I'm doing it this way is because I may repeat myself or repeat this throughout the video. Bear with me, because it's really important for you to remember that all raw arrays are zero based. The first element will always be 0, not sometimes, every time, every single time. So in order to get the first element of this raw array, we need element 0. In this case, it will be 1, because we're just going to go 1 through 5. And I'm going to use some copy and paste magic here and cheat a little bit because I'm just a smidge lazy. There we are. And I'm also wanting to use this to showcase how to access the last element within the array. Note the array size here, which would be 5. It will be this minus 1. So you have your however many elements are in your array minus 1 is going to be the last element. Because remember, it's 0 based, so it's going to be 0, 1, 2, 3, 4. So that tells you element 4 is your 5th element. And how to output this, you can just do it individually. You can probably predict what this is going to output. As you can see, there we are. You can also use the array name itself. And it ain't going to give you a number, but I will show you what it'll output, which is a memory address. And if you recall from the pointer video, in order to get the value of a pointer, we need to dereference that pointer. And it's the first element. You can also use pointer arithmetic to move around. And there we are. Pretty self-explanatory. Now, Every C programmer's best friend, and thus every C++ programmer's best friend, and I mean this sarcastically, is something known as undefined behavior. What do I mean by that? Well, let's just say, I don't know why I deleted that whole thing. Let's just say that we wanted to be a smarty pants. We wanted to access element 5 because we forgot about that rule I just named earlier. And what's going to happen? Element 0, or element 0, excuse me, value 0. Well, what if we just went to like element 20? What would it do then? Element 0? That don't make any sense. Well, welcome to what's known as undefined behavior. And it is also something carried over from the C language. Essentially, you're doing something that once you execute your code and the way you've got it defined, there's no telling what it's going to do because you are utilizing an array outside the bounds of what it's meant to do. So, like I said, if you're not doing the amount of elements minus 1, instead you want to just haul off and ignore this warning here and access element 5, well, let's just say we want to assign another element here and assign it number 6. Would it let us do that? Well, it sure did. Looky there. Now, like I said, this is what's known as undefined behavior. We are writing to memory that is outside the bounds of the array. But like I said, an array is just a collection of data that is stored sequentially in memory. So essentially, it's just writing to the next memory address, then the next one, then the next one, essentially. But not always. Thus the term undefined behavior. You can see why it's our best friend now. As you can see, that's that whole sequential thing I was telling you about. So, there we are. Now, let's talk about another type of raw array that's a little bit different, just a smidge, and that's the C string. So, what we need to do to create a C string is we need to pick on the character. And then from there, we will, oh yeah, one last thing before I get to the C string. I'm glad I remembered this. There's two more things I need to show you. First things first, you don't actually have to give the size of the array when initializing. You can use the curly braces to assign values to the array, and the array will automatically know its size based on how many values is within this curly brace separated by the comma. And then from there, we can actually use a loop to loop through this array. Come on now. Using just the less than operator because we just covered y. Here we are. And as you can see, we are simply utilizing the for loop to go through every single element within the array and output it. 1, 2, 3, 4, 5. And if you wanted to do it backwards, just to showcase it, since it's only 5 elements long, 4 is going to be the last one. Since we must access element 0 in order to get all the elements to display, we need to use greater than or equal to 0. And this time we're going backwards. And as you can see, there we are. So my apologies. I should have got that out of the way before mentioning C strings. So let's go ahead and jump back into C strings now. Okay. So once again, we'll throw the character in there, and we won't have to define the size because we're going to utilize these curly braces once again. And let's pick on the string hello. So we'll just assign this a character at a time. Alright, and then we're going to output it. Should be easy peasy, right? You're wrong. You see this little guy right here? This represents something bad. Actually, really bad. It could be really bad, essentially. But once again, it does represent undefined behavior, but it's actually a little more predictable, and it's known as a buffer overflow. And it's because we forgot another character that needs to be within every C string, and that is called a null terminating character. And essentially, a null terminating character is a backslash and a zero. Once again, that's a backslash and a zero contained within single quotes representing a character. Now we should have it displayed properly, and there we are. And that's the difference between a typical basic raw array versus a C string. It's that null terminated character. Now that you've seen kind of how to work with arrays, let's look at some objects within the standard library that we can use that's a lot safer. Matter of fact, let's go ahead and keep that guy there. Now, instead of using the C string, we can use something known as the standard string that utilizes essentially an object that does the same job as a C string, but with so much more. So with that in mind, I can show you a different way right quick, a safer way to initialize a C string, just to show you that if you use double quotes, for one, it already knows the size of the C string. As you can see, it deduced it, and it automatically adds that null terminating character when you use double quotes, and thus all is well. Now, let's check out the string object that is within the standard library of C++. We'll call this str1. That way there's no confusion. Call this str2. Well, dummy. There we are. Okay, now let's get the ball rolling. There we are. Hello world. So essentially it seems like it's doing the same thing, but not really. One plus about this versus a C string is a standard string keeps up with its own size. So for example, we can access what's known as a method using the dot operator. And there's something known as a size method. Go into that, and voila. But in order to do that with the C string reliably, you would actually, I'm pretty sure you can't do it within this. No, you cannot. So I'm going to have to access the header file from the C library known as string.h, and then output strlen, means string length, str1. Let me throw an extra end L in here so we won't be confused as we're comparing these two. There we are. So as you can see, strlen, it does the same thing as what the built-in size method does with the standard string. Also, a standard string is not null terminated, so you ain't got to worry about buffer overflows with a standard string at all whatsoever. So right off the bat, with the elimination of buffer overflows, a standard string is much more safer to use than a C string. So there's one big reason to use a standard string over a C string. Here's another reason why. If you ever need to use a C string instead of the standard string, if you absolutely need a C string, it has a method for that too, called the C string method. So that should eliminate any need to have to use a C string, because the standard string's got you covered. Now let's talk about those other data types and what we can use aside from them. You can go ahead and throw that integer array in there, called R1. And we'll do our old-fashioned for loop here. Access from beginning to end. Do it the fancy way. Oh, it's R1, not R. Give us a double inline here, that way we can keep them separated. Okay, so we can go ahead and build and run this, and you can probably guesstimate what it's doing here and how it's doing it. Pretty self-explanatory. But there are other things in the standard library that we can use to replace these raw arrays. And one such object we can use is known as a vector. Matter of fact, let's save the vector for now. I'll touch base on the vector here in a second, but let's touch base on the array first. There's actually a such thing as a standard array instead of a raw array. So what we'll do, we can declare array. Now these objects are templated, so we'll need to declare the type here. That should do it, unless I'm doing this wrong. Okay, that's what it was. So, with the standard array, it looks like you need to have the size already known, and then your defined types. So, good thing I started with this, then we can tackle vector here in a second. Now the difference between this one and that one is you can use what's known as a range-based for loop with these. That's about the only reason why you would want to use a standard array, to be perfectly honest with you. And a range-based for, in case some of y'all haven't done the research or bothered to look at it or know about it, we can do something like auto I R2 and C out I and if we go ahead and do that, as you can see, it does the same thing. So this cannot use a range-based for loop. This can. Now you can already see a kind of a humbug. We can say we have to know the size beforehand, whereas with this one we can base it on how much is in the curly braces. But fear not, there's another object we can use. It's a little simpler. It's the standard vector. That's what I was thinking of the first time, and I was like, oh wait, dum-dum, you're using a standard array, not the standard vector. So here we are. Here's what this looks like. So we'll declare our vector. It's going to be int. I'll call it R3, is assigned, and there we are. It's that simple with the standard vector. You don't have to know the size beforehand. It sets its own size, takes care of all that for you. Sorry if this space is bugging me. Okay. Once again, with everything in the standard library, we can once again use a range-based for loop. These range-based for loops require less to type, therefore very useful. And we should get the same thing. Voila. So consider using container types from the standard library instead of using raw arrays, because raw arrays can be dangerous. It's hard to determine which one's more dangerous, whether it be a raw array or a C string. They're equally about the same. Some would say the C string's a little more dangerous, but either or, they're all outdated. It's just a relic from the C language, and if you're welcoming yourself into C++, C++ has much better things within its library than the old. Out with the old, in with the new, guys. So with that, we're pretty much done with arrays. Containers pretty well for that matter. So if you like the video, please like, share, and subscribe. If I made any mistakes, please leave it in the comments below. And guys and gals, I'd like to thank you for watching, and happy coding.